Hello again, it's good to be back with you. One of the questions I get a lot is, what's a function? Mathematicians have defined functions and scientists and engineers use them a lot, but sometimes the abstraction of a function is hard to wrap your head around. So mathematicians tend to say things like, well, f of x is like a black box. You push a number in that we'll call an independent variable, or sometimes more than one, and you get a number out that's a dependent variable. And that's certainly true, but what exactly does that mean? Well, I can write some stuff on the board here. I can say things like, that's a function. Okay? If I plug 0 into it, I'll get 0 out. If I plug, let's see, pi over 2 into it, I'll get 1 out. Okay. That's, again, true. I'm having trouble here. Let's try an experiment. Let's try a demonstration. I think that'll work better. Before I go any further, I want to say hello to Mr. Brantley's class at Cumberland Elementary School. I hope you guys are learning lots this year, and maybe some of these videos will help. Okay, so what I've got here is 25 little tiles, and I made these today. I used a laser to cut these out of thin plywood, aircraft grade plywood. So see if I can get these in order here. There we go. That's a square, right? And if you count, there are 5 rows and 5 columns. Okay? 5 times 5 is 25. No problem, right? And if you want to look at it backwards, if 5 times 5 is 25 over 5 squared is 25. See, we got a square, so 5 squared makes 25. The other way to look at it is the square root of 25. That is, the number whose square is 25 is 5. So if there's 5 tiles on each edge, that means that this square that has 25 tiles in it, that square root must be 5. Well, what happens if I add or take away a row and a column? There. Now I've got 16 squares. Well, it's still a square. 16 squares with 4 on each edge. So the square root of 16 is 4. Right? Or 4 times 4, 4 squared is 16, and you get a square. All right, so do it again. Now I got 9. I got 9 tiles, and I got 3 on each edge. So 3 must be the square root of 9, or 3 squared equals 9. Squared, it's a square. Do it again. Well, I've got 4 tiles, and 2 on each side, 2 rows and 2 columns. So 2 must be the square root of 4. That means square root is probably a function. Let's see what that looks like. So we just made a list of numbers and their square roots. Is that a function? Sure. Here's what we did in mathematical terms. We wrote square root of 25 is 5. We figured that out, and then we went to square root of 16 is 4, and the square root of 9 is 3, and the square root of 4 is 2. In fact, the square root of 1 is 1, although we didn't go that far. So this suggests a pattern. All right? Well, if we wanted to know square roots or wanted to be able to keep track of them all, we could write down a long list of square roots and their numbers and their square roots. Big long list, and keep that with us whenever we needed one. Sounds kind of awkward. A more general way to do it, and because it's more general, it's more powerful, is to write this. Okay? A function of x is the square root of x. This is true for all numbers. Okay? I can put 25 in, and I take the square root of that, I'll get 5 out. If I put 16 in, I get 4 out. If I put 9 in, I get 3 out. If I put 4 in, I get 2 out. This works for all numbers. This is more general. It's an abstraction. That means it's more powerful. This is a much more applicable idea than this is, even though they work on the same principle. So even though we wrote it out with integer numbers as the output, does it have to be that way? Of course not. I can put this number in. I can put 8.5 in, and what I get out is the square root of 8.5, which is about 2.915. Okay, that's the square root of 8.5. So any number can go in and its square root will come out. Because this is a general idea, it works for all numbers. Now, not all of you will like this, but these don't even have to be real numbers. These can be complex. For those of you not familiar with complex numbers yet, that's another video. You can check that out too if you like. And then as I gotta look at my screen and see what it is, 1.674 plus 896i, 0.896i. So I pushed that number in and got that number out. Okay, that's a function. We started with a very basic idea, made it real using the tiles, using the patterns on the tiles, came back and made a general function, a more abstract idea that encompasses all of that, and found out that now it's applicable to everything. That's a function. That's why they're so useful. I hope this helps, and I'll see you next time.